Okay, we're going to look at acceleration. What acceleration really is a change in velocity. So here we see that sometimes we think about acceleration as going fast, we think about velocity as going fast. We can kind of get those terms confused. They're not the same thing. So look at the definition. Velocity is the speed and direction of an object. Remember that it is a vector quantity and it can also be zero. So you can have a stationary object, even though it's not moving, it still has a velocity. It's just that that velocity is zero. Acceleration is a change in velocity. So you're changing the first term here. There's three ways that can happen. So first we have centripetal, which is where you change direction that you're traveling. We also have speeding up, getting faster. We have slowing down. Now if you start at 0 and you go to 3 meters per second, that's speeding up. So if something starts to move, that's speeding up. If something comes to a stop, that's slowing down. So the formula for acceleration is delta v over t. So the change in velocity, whether that's a positive or negative, so if you're slowing down it's negative, speeding up is positive, divided by how much time it took to change that velocity. We measure acceleration in meters per second squared. We measure velocity in meters per second, and we measure time in seconds. Be aware that to find the change in velocity, you take the final velocity minus the initial velocity. So this is the final speed minus the first speed, or the starting speed. So looking at a sample problem. It takes 3 seconds for an object that is not moving to reach a velocity of 9 meters per second. What is its acceleration? So looking at how we're going to solve that, let me erase some things over here. And I always like to start by writing down the formula first before I do anything else. So I'm going to write down acceleration is equivalent to delta v over t. Sometimes I say delta t because you could have a situation where the timer doesn't start or something doesn't start moving until the second or something like that, but for right now this is fine. So again, acceleration is equivalent to delta v over t. So look at my information that I have here. I see that I have 3 seconds for my time. I see that my object had a final velocity of 9 meters per second, and it had a starting velocity of 0 meters per second. So remember that I said that 0 is a velocity, and so if I complete that and simplify that equation, I'll have my acceleration. So 9 minus 0 is 9. 9 divided by 3 is 3. So in this situation, my acceleration is equivalent to 3 meters per second squared. What this means is every second that goes, so again, this is the same thing as saying 3 meters per second. So every second that goes by, I'm going to add 3 meters per second to my velocity. That's what acceleration means. Let's look at the next slide here.
Excuse the interruption. If you're a parent of a Parsons student and you'd like to come up to speak with Ms. Perkins at this time, please do so. Thank you.
Okay. All right. Thank you. All right. So a car has an acceleration of negative 4 meters per second squared. It accelerates for 10 seconds, or really we should say decelerates because it's getting slower. That number is negative. Its initial velocity was 40 meters per second. What was its final velocity? So you're going to have some problems like this. Let's kind of simplify this and talk about how we solve it. All right, so we have our acceleration already. That acceleration is negative 4 meters per second squared. We know that the time it takes for it to slow down, and again, slowing down because that number is negative, is 10 seconds. And we know that its starting velocity was 40 meters per second. So we need to find out what the final velocity is. So the way we're going to solve this is we're going to try to simplify everything that we have in our formula here. I'm going to multiply both sides of the equation by 10 seconds, and when I do, I get negative 40 So basically, if you divide by 10 and multiply by 10, that just cancels out. So I get negative 40 equals velocity final minus 40 meters per second. If I add 40 to both sides, what I'm going to get is that the velocity final equals 0. So that's how so basically what we have going on here, again, that's meters per second. What we have going on in this situation is we have something that's traveling at 40 meters per second, and then over the course of 10 seconds it decelerates until it comes to a complete stop. And so that's the situation, that's what it will look like. Alright, so go ahead and complete your fever form, and if you have questions, let me know, and I'll be glad to help you.